clearly first describe the critical power, and it is generally described as a threshold of aerobic function that corresponds to the highest work rate for which steady state in VO2, arterial blood acid base status, and so on can be achieved. So it is the highest intensity where you can have a rich and complete steady state. It demarcates the upper limit of the whole aerobic energy provision. And the W, that is more or less the curvature constant of the hyperbolia for the relationship between power output and time to exhaustion, it is mathematically equivalent to the amount of work that can be performed above the critical power. So if you want to be efficient, if you want to have a long time to exhaustion above critical power, it means you need to have a very large W. How does it relate with the VO2 kinetics parameter? In this study, for the first time, they just show that if you have a fast kinetics, I just remind you, a fast kinetics means a short constant time. Here, then you will have a high critical power. The way your VO2 will change when you change the intensity is very strongly related to the upper limit of your aerobic energy provision. That is a very interesting and very fundamental point. In the other way, we just mentioned that W is the amount of work above critical power. There is a positive relationship between this ability to sustain an exercise above critical power and the amplitude of the VO2 slow component. In other words, if you reduce your VO2 slow component, then you will reduce your ability to perform above critical power. That's why VO2 kinetics, in the view of Arnold Jones, and I'm sure you start to understand also in my view, is something that is so important to be measured and so difficult, and probably also it is quite difficult. That's why we don't have so many data. Okay, so let's go to the traditional parameters. First, we're gonna discuss what we know about VO2 max and aerobic threshold. And again, we discuss VO2 max and aerobic threshold. We're gonna talk on heart rate and running equipment. So VO2 max, as you know, is a parameter that has been probably the parameter the most measured in sport, in on-demand sport. Probably also because it is one of the easiest one to be measured, and it reflects the capacity for the cellular oxidation utilization in a specific activity. We are talking here about the MAF VO2, the one you can measure with a gas analyzer. And the traditional accepted hypothesis is that VO2 max is directly related to the muscle mass that is involved in the activity. So this type of test, where you have incremental round test or incremental test to exhaustion, you're going to reach a plateau, define VO2 max, and you're going to find also the velocity or the power associated to VO2 max. Something that you don't know. A lot of studies, about 21 so far. It's a table that comes from Veronica, that we did publish in Sportsman. A lot of studies did compare if in cycling and running, triathletes have the same VO2 max than the cyclist and than the running. It is, in other words, to better describe the specific adaptation. When you train only in one sport, will you get a different VO2 max than when you train in different sports? Running involves more muscle mass than cycling. That means that traditionally, it's not clear in this table, but traditionally you will get a higher VO2 max on treadmill than on cycle. except for the cyclist, and we can read this sentence that if you have a long training in history, and especially in cycling, then you can elicit VO2 max values that are similar on cycle ergometer than on treadmill, and for the elite cyclists, that can even be higher. In triathletes, it is a mixed model between the runners and between the cyclists, and it is largely depending on your training history, on your training background. If you have a cycling background, then it is likely that your VO2 max in cycle ergometer and treadmill will be similar. If you have a running background, you will keep the differences that are generally observed. A wrong fact on VO2 max is that it can be limited. Sometimes some people will tell you after the age of 18 you will not improve your VO2 max. After the age of 20. This data comes from cross-country skiers in Finland, and you can see that there's a long increase in VO2 max per kilo per minute that is closely related to the increase in the mileage. But it is true that after the age, let's say in the senior category, after the under 23, you start to observe a plateau of VO2 max. So is it worth to measure VO2 max in the elite athletes on a regular basis? Question mark so far. But definitely this data show that it is a key parameter to be measured in the youth, junior and under 23 categories. If we observe this data from Paula Radcliffe, that is a current marathon record holder, 2 hours 15, that's quite an amazing results for a woman. Between 1992, she was running 2 hours 25, and 2003, where she had the world record, you can see there's no change in her VO2 max. She has largely improved her performance by more than 10 minutes. She didn't change her VO2 max. And at the same time, the velocity associated to VO2 max did improve. So this parameter that is a technical approach of this, means the translation to the field of this parameter is much more relevant to be assessed than VO2 max by itself. We got some data in elite triathletes that are data from the French team in the 90s, and you can observe here that if I compare the elite Olympic distance men, the elite long distance men, and the junior, they've got about the same value in VO2 max. Obviously, the junior and the Olympic distance, that was a French national team, they had about 2 minutes in terms of their 10K running performance. But it's not reflected by their VO2 max. Same type of data for the women. So after junior or after under 23, what's the point to measure it? Here it is a graph to show the differences between running and cycling, and as mentioned before, the runners will have a large difference, and the more elite you are, the larger the difference when I compare treadmill VO2 max to ergocycle VO2 max. Same for the cyclist. The cyclist will have a higher VO2 max in cycling, and the difference is larger if you are elite. And for the triathlete, it is an intermediate results. So definitely there are some efficiency. So there is some efficiency of cross-training in this slide. Let's go now to the other